So thank you for that brief introduction. Like you said, my name is Hannah Kessler, and I'm a second-year master's student in the O'Reilly Laboratory. Our research primarily focuses on synthesizing potential antibiotics for treatment of antibiotic-resistant infections, and my work is specific to methicillin-resistant Staphylococcus aureus, or MRSA. Even though we already have great antibiotics on the market, bacteria have started to become resistant to these types of treatments. In 2019, there were 2.8 million antibiotic-resistant infections, and 323,700 were related to MRSA, causing more than 10,000 fatalities. Therefore, new medications for bacterial infections are urgently needed. Emicin is a functionalized dihydropyrimidine compound that was discovered by the Spring Group in 2008, and it was shown to successfully inhibit the growth of MRSA. It is believed to work through dihydrofolate reductase inhibition and is a promising lead for further development of antibacterial agents. Compared to the many other classes of antibiotics, such as the 34 approved beta-lactam antibiotics, all working through the same mechanism, trimethoprim is the only FDA-approved antibiotic that works through inhibiting dihydrofolate reductase, making it an underutilized antibiotic target. We developed a library of functionalized dihydropyrimidines by making small changes to the molecule. By making these changes to the compound, we are analyzing how it will bind to the target. For example, if we add or remove a group of atoms to the compound, it may interact with the enzyme more or less favorably, which will impact its potency among other properties. We're also studying the bioactivity of these analogs by using methicillin-sensitive Staphylococcus aureus and MRSA strains that were hospital and community acquired. Some of our compounds have shown inhibition as low as 8 micrograms per milliliter, and we're looking to test at lower concentrations in the near future. Lastly, we wanted to confirm the mechanism of action of our compounds as we hope they inhibit the underutilized antibiotic target, dihydrofolate reductase. Toward this end, enzyme kinetic assays are being used to investigate the ability of our compounds to inhibit their presumed target. Preliminary studies indicated our compounds provided modest inhibition of the enzyme, but we are still testing different variables to make this assay more reproducible and will be continuing throughout the fall and spring semester. I would finally like to thank the College of Liberal Arts and Sciences for the funding that they provided this summer to carry out research. Thank you.
And thank you, Hannah, for those kind words. I really appreciate that. Questions for Hannah? Yes, Emily.
Is there a danger to studying this in a lab? Like, how do you prevent? This is a layperson's question, but.
No, there's no danger to studying this. No, we use a biosafety cabinet, so that kind of keeps everything sterile in our lab. So it's pretty safe.
That's a good thing.
Yeah.
All right, thank you so much,
Thank you.
Hannah.